Hey out there again, this is Bob with JD Squared. Like to apologize for the background noise. I am filming this during working hours. It's very hard lately to get any kind of quiet time around here. They're working a lot of OT trying to get through backlogs, stuff like that. Anyway, this is an RC6 instructional video on our rotary cutter, and it's going to address the square tube stabilizer, and that's what this is right here. Well, I got it in my hands. When we go ahead and bolt this thing into the machine, there's a little sliding plate right here. I just want to show you that now. We're going to be locking that down after we have the device in the machine and adjusted, and then that way next time we put it in, we're not going to have to worry about alignment. It'll already be there. As you can see, it has a rotating disc. We have 4 adjustable yokes on it, and we also provide two additional pieces, and that's this right here. And I will be showing you how they work. Opposed to other designs out there on the market, when it comes to handling angle iron and channel, we have decided to use these yokes where we replace 2 of them in the unit, and the idea being is that the yoke is going to drive against the inside of the angle iron. We found that to be much more reliable than trying to use the 4 rollers and grab it this way. Anyway, the capacity of the square tube stabilizer is 4 inches by 4 inches square. Anything inside of that envelope it can handle. Very free turning device. It's designed to be rapidly put into the machine and taken out of the machine. Therefore, the distances between the mounting and the center of rotation is the same across all of our adapters, whether it be the round tube stabilizer or the square. So once you've set the machine up for one, you can easily switch between the 2 right there. All right, let's go ahead. And the first thing I think we need to do is go ahead and bolt it into the machine. As you can see, the RC6 already has the round tube stabilizer mounted in the machine. Let me go ahead and move this forward out of the way. You can see it a little bit better. Let's move the torch to the rear. We're going to go ahead and move this forward. All righty. I have gone ahead and disconnected the air supply into the machine. I need to do that because we have to remove the round tube stabilizer so that we could bolt into the square tube stabilizer. I've also disconnected the air to the stabilizer right there so we don't have a problem with that. So I'm going to walk around behind the machine, and I need to disconnect the electrical wire running to the stabilizer. Simply push the connector. Now I'm going to come over here and I am going to remove the 2 pneumatic lines and I'm going to replace them with the plugs. I'm putting the plugs in the solenoid. Alrighty. Okay. That's all done. Now what we need to do is go ahead and remove the stabilizer from the machine. There's only 2 bolts back here that are going to do that. Pretty easy to do. Let's see. Alrighty. Okay. These are our 2 lines, by the way. These are our 2 pneumatic hoses, and that's our electrical connection. Go ahead and roll that up right there. Didn't mean to drop that. Alrighty. So I'm going to go ahead and undo the 2 bolts and remove it. I've already loosened them with my wrench, so it's fairly easy to remove now with my fingers. There's 1. There's 2. Okay, and that, my friends, is the round tube stabilizer. Let's go ahead and put it over here. I think it weighs about 35 pounds. It's not all that bad. Now we're going to go ahead and look at the carriage. Right here we have a mounting adapter that we supply with the machine, and it is capable of being placed into 3 different positions: middle, fore, and near. Now, the reason you would do that was if you were doing large notches or something, you may want to have the stabilizer further away from the torch so that you don't have an issue of where your rollers are actually rolling into any cutouts you may have already made in that piece of tubing. All right, let's go ahead. We're going to bolt this up right here. I've got the plate moved out of the way so that I know it won't interfere. I'm going to set it on top of the adapter, and what I'm going to do is I'm going to bolt it down with a single bolt. Let me see, got to look down in there. All right, I'm placing both bolts in the machine, but we're only going to be tightening one of them right now. So let's go ahead, put the rear bolt in, and the rear bolt's the one we're going to want to work with. We don't really even need the front bolt in, I just put it in just to get it out of the way. Okay, that was fairly simple. We've already got the stabilizer mounted, so the next step is to align it. So let me go ahead and get the alignment piece, and we'll do that. I've gone and got a piece of 1.5-inch round tube. This was the same piece of tubing I used in a prior video where we were installing the round tube stabilizer. I'm going to go ahead and place that in the chuck right here. We'll let it stick out about 6 inches in that neighborhood right there. Let's see. Go ahead and tighten that up. Alrighty. Now, if you remember, the stabilizer is loose. By the way, I accidentally referred to this as a stabilizer in a prior clip. It's actually a lifter, I'm sorry. All right, another thing I forgot to mention when I bolted it in is why would you want to move to the different positions? I told you you could, but why? The reason is generally you want to be cutting your tubing as close to the torch as you can. You want the rollers as close to the torch as you can. Having said that, we've discovered that the middle setting works really good for almost all settings, so that's why that's there. Now, what we're going to go ahead and do, we're going to go ahead using our fingers, and we're going to open up the yokes as far as they'll go, right there. You'll see it a little bit better in a minute. Then we're going to go ahead and we're going to retract the whole unit. Now, in the video discussing how to install the round tube stabilizers, I had gone ahead and showed you how to do the bump stop. I'm going to go ahead and do the same thing for you right here. All right, so what we want to do is, since I took out the round tube stabilizer, I know for a fact that if I retract this, I am not going to hit the chuck because the round tube stabilizer was wider than this one right here. So let's go ahead and run it back. All righty. We are a good 6 inches short of the chuck, contacting this right here. So I'm going to go to the rear of the machine. I know that I'm in hole number 4 on the bump stop. I'm on this hole right here, and I'm on hole number 3 of the 12mm tapped holes. There's 4 of them. I'm on hole number 3. So I know if I back up about 6 inches or so, let's go to that hole right there. I place it back in the machine. I'm even going to place it back into the same hole because it really doesn't matter. Now I can come back over here and I can run it back a little bit further. Oh, I'm sorry, we got to rehome that axis because we just changed it, right? So we're going to go to the home icon up in the top left of the screen, and I am going to select home Y. It's asking me, do you know that there's a lifter in this machine? If so, make sure there's no material in it. Okay, we still can back up a little bit more. I'm going to go ahead and I'm going to move that bolt one more position forward so that we have absolutely maximum range of the machine when it comes to the tube itself. Alrighty. Now this time I'm going to go ahead, use my 19mm wrench. You can also use a 3/4mm wrench, and I am going to tighten down the bump stop. Let's go ahead and home the Y-axis again. Once again, yes, I know I have a lifter in the machine. And there we go. We're looking really good right now. You can see the yokes right here. They'll bump against the material, and we're in our right position. By the way, the Y-axis is the long axis. The X-axis is going this way. In other words, the torch is moving in and out. And of course, the Z-axis is up or down. All of our machines have labels on it identifying the axis. They also have a do not put your hand in here stickers, you know, because there is a little bit of hazard. You don't want to ever be around the machine or inside the machine when it's operating. That's a no-no. All right, let me go ahead. I'm going to reposition the camera so that I could show you how to adjust these rollers. You know what? Before I do that, let me give you an idea why I designed it the way I did. I've looked at, obviously, there's other ones on the market, other machines on the market, and one of them, it has 4 rollers where you tighten up the rollers, they come together, right? We found out real quick that kind of design, in our opinion, had a major flaw, and is that it's a fairly weak structure. because the little spur gears that are holding the independent or the opposing rollers aren't any bigger than your thumb. So you're very limited to how much weight you can put on them. You just shear the teeth right off them. And the other thing is too, it was very, very large. So we didn't want to do that. We wanted something that had very low rotational inertia so that we could spin it easy with small tubing. And we came up with this design right here. Now, what I was looking for was max strength. I want this thing just to be 24/7, 365, no problem. So the way we did it was we make it to where you're going to adjust 2 of the yokes to an absolute position. I'll show you how to do that in a minute. It's super, super simple. And then you're going to lock them down. Now, if you look on the back side of the machine back here, it's all threaded. And we have bolts. Let's go ahead and take this top one out right here. Okay, you can see the bolts coming through the back side. What I've done is I've tapped the rotary disc so that you don't have to keep screwing a bolt into it, thereby stripping out the bolts. Now, if you were going to use the full range of the lifter, there's 2 positions. You may have to back off. I think it's a 90 millimeter, 12 millimeter bolt. Back it off, put it into a lower hole, and that will allow you to go to the smaller sizes of tubing. Alrighty, let me go ahead now and get another piece so that I can show you how we actually align these things here. In order to show you how to adjust the stabilizer, I've gone ahead and picked up another riser block. There's actually 2 of them in the machine on opposing sides. If you look at a riser block, it has a groove that the yoke itself will slide up and down in. It has a ruler type scale engraved in it, and it has a roll pin. The exact same markings are on the steel ring on the yokes that don't utilize a riser. The idea is if you look at the yoke, there's an indicator mark right here, and then you have the ruler here. You could adjust the roller to where you want it for whatever size tubing you want by lining up the indicator on the ruler markings, let's say at 2 inches, and then locking the system down. That's one way of doing it. That gets you pretty darn close. The best way to do it, however, is we've gone ahead and made different stainless steel gauge sets. So this particular gauge set right here will handle 12 different sizes of tubing, the most common up to 4 inches. And they essentially are cut and labeled or engraved with the size of the tubing that you're going to be loading into the machine. So for instance, if you remember, I loaded up a piece of 1.5 inch tubing right here. What we would be doing to adjust the yoke is taking our 1.5 inch gauge, placing it between the roll pin and the flat face here, rolling them together, and you end up with this right here. So this is telling us that's where you need to bump against the roll pin in the back side. And if I look right here, I don't think you can see it, the indicator is on 1.5 inch. So that's how we're going to adjust it. Once we have it where we want, we're going to tighten it down. Now, a quick note. Most people are going to be working with 2 inch and smaller square tubing. So there's 2 locations where you could put the bolts, as I explained earlier. On the inside location, you're able to go from 2 1/4 all the way down to about 1/2 inch. Now, if you go to the outside, which is for the large stuff, 4 inch, 3 inch, you can go down to 2 inches, actually a little above 2 inches, all the way out to 4 inches. So that's where you're going to know that you need to remove or replace the bolt into another hole, is the range that you're working with right there. Alrighty. Let's go ahead and adjust the rollers that are in the machine. We're going to go ahead and we're going to line up the rings center of rotation with the chucks. Very simple. First thing we're going to need to do, remember the entire mechanism is still loose. We haven't locked the bolts down. Let's go ahead and slide it all the way towards us. You got about 3/4 of an inch travel that you can move it. We're going to move it all the way towards us. Now, we're going to go ahead, since I have 1.5 inch tubing loaded in the machine, we're going to take the 1.5 inch gauge. We are going to we're going to put it in like that right there. In fact, I'm just using friction, pulling it back. We're going to go ahead and snug our nut down here. Alrighty. Now I'm going to go ahead and use a socket wrench on the back side The only reason we need that is because you can't get a regular wrench in there. The bolts that are in there are actually securely tightened down already, so the ratchet is really just helping us prevent from spinning the chuck. Alrighty, so we've got that there. We've got it adjusted for 1.5 inch, which matches our 1.5 inch round tubing. Now, don't ever be tempted to adjust these things with a piece of square tubing. Remember, we only have to do this one time when you buy the machine or buy the stabilizer. Once it's aligned, it will always be aligned no matter what you do. So go ahead and use round tubing, preferably 1.5 inch works really good. All right, the next thing we need to do, this whole thing is loose. We're going to carefully slide it towards the tubing until it contacts the tubing. The roller here hits the tubing. Now what we're going to do is slowly tighten down the rear bolt because we have sag right now. This whole thing's sagging a little bit and we want to take the sag out. And I'm still making sure that I'm on the roller. I am. Okay, we're going to bump it just a hair. Oh yeah, that's really good right there. Let's go ahead. Now I can go ahead and tighten these bolts down pretty tight back there. We have now aligned the stabilizer in this direction. So the next thing we're going to need to do is align the power head up or down. And the way we're going to do that is in the previous video, I had already set the power head to a correct height. You need to watch that video. I described in it how to take a 10mm bolt with a nut and a coupling nut and make an adjustable spacer that once you lock it down, whenever you're going to put a stabilizer into a machine, you simply place that bolt underneath the lifter plate, let it rest down on that bolt system that you just adjusted, tighten your nuts down, the lock nuts, and you're good to go. You don't have to keep adjusting, doing what we're doing. You're only going to do this one time. Anyway, watch that video, you'll see how that's done. Now that I've bolted this in, remember that little sliding plate I showed you earlier? We're going to slide it towards the, okay. We're going to slide it towards the back mounting plate right here, and then we're going to lock it down. So the next time we put in our stabilizer, we just place it on the mounting bracket, slide it back carefully until that stop plate hits the bracket, tighten everything down. We don't have to keep going through this alignment procedure. All right, let's go ahead and set the height of the chuck. One thing to keep in mind, that the square stabilizer versus the round stabilizer, the square is a more accurately machined piece. And the reason for that is we use transfer balls in the round stabilizer, and they have a certain amount of tolerance, just the way they are. That's the way we get them. We typically measure anywhere from plus or minus 15 thousandths of an inch, which isn't much. That means if you had aligned the power head using the round transfer stabilizer, you're not really going to be a problem. It's not going to be a problem. You're going to be off maybe what, 15 thou. However, I like to align the power head and set that little bolt gauge I was telling you about using the square stabilizer because it is more precise. So what we need to do is take the wrench that we provide. On one end, you have this little pivot rod that we're going to use to raise and lower the power head. On the other end, you have a wrench. Now clearly, if you're getting ready to do what I'm doing right now, you have the machine. You'll be able to see it fairly easily what I'm doing. Anyway, let's go down here. I've got to break the lock nuts loose on the bottom, and I am going to ever so slightly raise the head up. Alrighty. Now, this is the yoke that we just adjusted. If I rotate it to the vertical position, which isn't going to work, I'm sorry. Did I say raise the head? I need to lower the head. Let's get it on down. All right. Yeah, that's it right there. Okay. Now, I can rotate the fixed yoke that we just tightened down to the 12 o'clock straight up position. It spins free. I've got about an 1/8 inch clearance between the roller and the tube. So now we're going to raise the entire system. I could do it, by the way, with a couple fingers until I see it contact the roller very slightly. Verifying that the roller has got a little bit of play on it. And what I'm doing is I'm raising a lever and I'm using my fingers to tighten it. Oh yeah, that's real nice right there. All right, I'm going to go ahead, tighten up the lower lock bolt, or lock nut, I'm sorry. All right, there we go. Believe it or not, we are finished. We have got the stabilizer in. It's all adjusted. Now, the next thing we need to do is go ahead and set that little bolt gauge I was telling you about from the round tube stabilizer, so that we can easily replace the power head in the right position next time we put it in. It's very, very simple. Alrighty, let me go ahead, and we're going to go ahead and load up some tubing in this thing and cut it so you can see how it operates. I've decided I'm going to go ahead and use 2x3 tubing for this example. So what I want to do is I want to mark 2 yokes that are side by side, and these are going to be my fixed yokes. So we'll mark one, we'll mark it, even though I already marked it. So we have 2 yokes that are marked. And these are the 2 that we're going to adjust to handle our 2x3 tubing. Now, remember I mentioned that the inside hole you could handle up to just a little bit greater than 2 inch, and the outside hole it's 2 inches up to 4. So I have 2 of the bolts repositioned to be on the inside position to handle the 2-inch side of the 2x3, and then 2 to the outside on the riser block. So we're going to go ahead and adjust this riser block to 3 inches. Very, very simple. We grab our 3-inch gauge right here. Now, by the way, these gauges, we can make them in millimeters, custom sizes, or whatever. This is why we went to this design. It's a very versatile system, very easy to adjust. Anyway, let's go ahead and we're going to slide it out. You can see there just me holding it right there will keep the gauge in place. And we're going to go ahead and snug it up a little bit. Now I will take my socket wrench on the back side, and we are going to tighten this bolt down here. Now we want to tighten it down fairly tight. There we go. Now we can go ahead and pull the gauge out. Everything looks good. We've just adjusted that for 3 inches. Now, this one here next to it, the other one we marked, we're going to adjust it to 2 inches. So let's go ahead, slide it down. All right, let's see, 2 inches, yep. Pull it up against the gauge right there. You know what, I'm going to have to put one of these wrenches down. All righty, here we go. Let's go ahead and snug this one up. All right, the gauge is still there, you can see it. Let's go ahead and tighten that one down. And that's it. That's all that it takes to adjust the stabilizer to handle 2x3 square tubing. Fairly simple. All right, let me get my tubing. We're going to load it up, and then we're going to cut it. I want to go ahead and move the carriage to a little bit further away from the chuck to load up our sample piece. First thing I need to do is go ahead and drop the lifter. That's the subject of another video. Now I can go ahead and move the carriage down. Alrighty. At this point, we're going to go ahead and take the 2 yokes that we had marked, and we're going to move them both in the lower position so that the rollers form a V so that we can lay our tubing in it. Now, there's many ways to grab a workpiece with the RC6. We're using a synchronous 4-jaw chuck right here, which means all 4 jaws are moving in and out even with each other. Since we're doing 2x3, we're going to go ahead and cheat. We're going to take a shortcut, and I've gotten 2 pieces of 1/2-inch metal right here, scrap, and we're going to use that to space the 2 jaws that won't contact the 2x3, because 3 minus 2 equals 1 inch divided by 2. We have 2 1/2-inch pieces. Let's go ahead and slide the tube up into the machine. Okay. Alrighty. Let's bring it on down here. Now at this point I can easily rotate it. It's not a problem at all. We need to go ahead and put our 1 spacer in. Go ahead and put our other spacer in. Now we do manufacture a pretty slick device that does this and also handles angle iron and everything. It's called the universal jig plate, I believe. Anyway, check that video out, because if you're doing 2x3 rectangular, you're not going to be able to use the chuck very easily. You're going to want to use that other device right there. Okay, there we go. So what we need to do now is let me go ahead and move the torch out of the way a little bit more. There we go. We have to go ahead and take the 2 jaws that were not locked down earlier, the ones that we marked with the magic marker, these right here, you can see it moving. The two that have been marked, they're on the bottom. Let's go ahead and rotate a little bit. If I hit the delete insert keys, I can rotate a little bit. There we go. The reason we did the V is because now the rectangular tubing is sitting down on the rollers real nice. All we have to do at this point is literally just let the yoke fall against the tube and then tighten it up. We'll snug that one up. We're going to do the same thing to the back one back here. We're going to snug it up. Then we're going to get our socket wrench and we're going to tighten them up. Okay. And we'll do this one right here. That's it. We're basically adjusted for 2x3. We can go ahead and spin it if we want. I did tighten it down, right? Yep. We can go ahead and spin it. There you go. Easy peasy. Now, the next step is for us to go ahead and tell the machine where the square tubing is and to also make the square tubing flat in relation to the machine. So what we need to do is first rotate the tube so that the large flat side is facing up. Now, the reason I did this was when I generated the program in Camelot that we're getting ready to cut, it started on the wide flat side. So that's why we want it facing up. And now the way you verify that is just go into Camelot and hit animation and you'll see the torch come down and it'll animate the cut for you so you know exactly where to start from. All right, we have provided wizards in the RC6 that will help you align this up. If I go over here to the right side of the screen, I select plasma and I select wizards. We have a square tube or rectangular tube wizard, and we also have a round tube. I will post up a little close-up shot of this. You can see it also when I did the round tube stabilizer. I zoomed in on the screen. You can see it pretty clearly, but you'll understand what I'm talking about as I tell you. Anyway, I've got the square rectangular probe up, and what it's asking me for, first thing it wants to know the tube width. Now, what it's thinking of is the width is this away. So that's going to be 3 inches. So let's go ahead and set that to 3. The tube height is what the machine is going to be looking at for the Z-axis, which is going to be 2 inches. Now the other thing it's asking for is the radius of the corners. And that has to do with the fact that we have a tapered nozzle right here and we're using the nozzle as the probe. So let's go ahead and we're going to type in 0.25. It isn't that critical that you get it right. Just we got to have a number in there. All right, now what we're going to do is we're going to generate the program for the machine to run and square the tube. So I hit the generate button. I go back to my plasma screen. Now that program that it just wrote has been loaded. Now what we need to do is move the torch to the middle of the tubing. Let's go on down a little bit. See where we're at? A little bit more. We want to be within 1 inch or so from the top of the tubing and roughly in the middle. So let's move over just a little bit more. There you go. Now, using the insert and delete keys, I could rotate the tubing so I have it relatively flat right now. Anyway, all I have to do now is hit the run button. It's going to come over and it's checking the farthest out point it can. That's why we put the corner radius in so it'd know how far it could go out. It basically just squared the tubing right there. Now it's looking for the outside edge. Now the inside. This is going to tell it the center location. All right, we rotate around. It touches off. That's it, we're done. The machine now knows where the 2x3 is, and it's time to run the program. Let me reposition the camera so you can see the cuts a little bit better. The next step is we have to go ahead and tell the machine where do we want to start cutting this program. So we are going to raise the torch up a little bit, and we're going to move to the end. And that looks pretty good. I'm about 1/4 inch in from the end, so we'll start there. Now what I've got to do is I have to tell the machine where on the y-axis are we going to start cutting. That's the 0 point. I've moved the torch to where I want to set that. So I'll come over here to the control panel and I will select Y0 under the quick work offset. The machine now thinks that when it runs that program that this exact point is 0. So we've done that. The next thing we need to do is let's go ahead and get the torch up out of the way right here. We need to go ahead and tell it what material are we cutting, because this is the first time we've loaded this workpiece into the machine. So we're going to come down here in the lower left, we're going to hit plasma configuration, and we're going to hit the button select settings. Over here we're going to pick our power unit. It's in Power Max 85. We have mild steel. We're going to be cutting 10 gauge thickness, flat material, fine cut, shielded consumables. We're done. We hit OK. It populates the lower left panel, plasma configuration, and it tells you where to set the hypertherm or your plasma unit at as far as amps go. And it told me 45. I've already done that. At this point, we can go ahead and cut this part. I'm going to go ahead and reposition the camera again so I can even show you a little bit better. That's all there is to it. We've cut our piece out. I'm going to show you something pretty cool here. What this piece is, it's a wedge cut. And we've been working for quite a while now on getting our software to generate wedge cuts. And this is what happens, is when we cut the wedge, we put it in a press, we bend it down, and we end up with that look where you don't have the cut on the outside. We've got it, the machine working beautiful doing that. The software is working great. I can't wait to shoot that video and show off to you about how well this machine cuts that. But anyway, that's the cut. We would take a slit saw, cut this out here to drop it out. We didn't want to let the whole piece drop out because once again, we're running rollers over it. So we used the split function in Camelot to keep this part intact. That's really all there is to talk about setting up and aligning the square stabilizer system. There is another thing that it does extremely well, and it's handling angle iron, channels, stuff like that. But as I've been making this video, I'm really thinking that may be best to do in its own video. Essentially, what we've got is what we would be doing is taking out two of the yokes, the two that we did not permanently set, and replacing them with these yokes right here. And as I mentioned earlier, these yokes will grab the inside of the angle iron. So let's do that in another video. I think it'd be a little bit better that way. Anyway, that's it. Really can't think of anything else to tell you. I really appreciate you taking your time out. Hands are all dirty. Thanks a lot. Have a great day. Goodbye.